it didn't record the last session for some reason. I thought I hit record, but apparently it didn't go. But I'm recording this one. So let's take a look. We're looking at section 4.4. And we're going to be adding polynomials, adding and subtracting. So let's say we have this. Now, since there's nothing outside the parentheses multiplying, we can drop the parentheses. And so we're going to combine like terms. So we want to know the like terms. So this is a type x squared. This is a type x, and that's a type constant. Now these are three different types, and they're different because of either variable or no variable. And then the exponent. Exponents will give you a different type. Different exponent, different type. So in this case, you have a type x squared and a type x squared. There's two of them, so you have two x squareds. There's 5 x's, 3 x's, that's 8 x's. And then 4 plus 4 gives you 8. So questions about that? Now, this is a situation where we could just drop the parentheses. Let's say it's got a minus sign. Let's say we're subtracting. So let's say we have this. Now, in this case, there's nothing in front of the parentheses on this one, so we can drop the parentheses. But this one, we got to distribute that minus sign. So the minus sign, anything outside the parentheses here is going to get distributed. So minus to minus will become a plus. Again, minus to minus will become a plus. Minus the positive becomes a minus. And now we combine like terms. 5a squareds, 3a squareds, 8a squareds. You have 2 a's, subtract an a, that leaves you with a single a. Negative 4 minus 4, I'm sorry, negative 6 minus 4. Or if you have negative 6 degrees, drop the temperature 4 degrees more, or 4 more degrees, get negative 10. So questions about that? So that's pretty much it for adding and subtracting polynomials. Now, next what we're going to look at is multiplying monomials, or polynomials and monomials, and then also polynomials and polynomials. So this is section 4.5. So let's say we have this. Now, again, we've got something on the outside of the parentheses. So that's going to be distributed. So that 4x squared y goes to each of these terms. So now we're just going to multiply like we did in the previous sections. So 4 times 2, that's 8. X squared, x cubed, that's going to be x to the 2 plus 3. Y times y, well, that's y to the 1 plus 1. 4 times 3 is 12. X to the 2 plus 2. Y to the 1 plus 2. 4 times 8 is 32. Then we just have an x squared and then a y to the 1 plus 3. So this means 8 x to the 5th is what we get here, plus 12 x to the 4th, y to the 3, plus 32 x squared y to the 4th. And it's tempting here, and we should look for it. Are there any like terms? There actually aren't. This is a type x5, y2. This is a type, x4, y3. And this is a type x2, y4. They're totally different. Now, let's say this one was an x2, y5. Well, it would still be different from this one, x5, y2, because this one would require the x to get the 5 and require the y to get the 2. So this is the best we can do. And we're done. Questions about that? All right. Now, this is monomial times a polynomial. Now, another kind of multiplication we did was binomial times binomial. Now there's a shortcut for this. Now there's a way you can do this. You can take this binomial and distribute the entire thing to the 2x and do the -1. You could do that. But we're going to use FOIL. So what FOIL means is first term of the binomial times first term of the binomial. And then outer term, 3x, and we bring the sign with it. So this will be 3x times -1. And these are the outer terms of the entire multiplication. Then the inner terms of the entire multiplication. And then the last terms of each binomial. So this will be 6x squared plus and minus 3x plus 12x plus -6. Now these we can combine. You got 12 x's, you lose 3, you're going to get 9x. And we still have our 6x squared plus. And then we have a -6. And then that's it. That's going to be our answer. Questions about that? So the next kind of problem we're going to look at we're going to do this 2 different ways. We're going to do it the hard way and the easy way. So if you ever forget these tricks, you can always do this the hard way and just be careful so you don't miss any steps and then just kind of hammer out your solution. So the hard way works like this. We'll distribute our polynomial to every single term. Now this description of using the distribution to each term, it's called the rainbow method. I had a student once come up with this method. I thought it was a neat way of describing how to do this. So we distribute this polynomial to each of these terms. And so we get the x squared times the polynomial, the 4x times the polynomial, there's the minus sign. Then we have the 3 times the polynomial. And now we got to use that rainbow again. So this will become 2x to the fourth plus x cubed plus x squared. Now, because of the minus here, I'm going to keep the minus and the parentheses. 4x times 2x squared is 8x squared. 4x times x is 4x squared. And 1 times 4x is 4x. And then this one, oh, I'm sorry, made a mistake. 4x times 2x squared is 4x cubed. Don't forget the x cubed. And then this one, it'll be 6x squared plus 3x plus 3. Now we distribute the minus sign. And so that's what we get. We distribute the minus to all these positive terms. So the positives become negatives. So now we're going to combine like terms. Now there's only an x to the fourth term. There's only one. That's 2x to the fourth. Now if we look at our x cubes, there's an x cubed, a minus 8x cubed, and that's it. So a 1 and a negative 8, that's a negative 7. And then a 1x squared, a minus 4x squared, 6x squared. 1 minus 4 plus 6 plus 3 x squared. Now for type x, minus 4x and 3x, or minus 4 plus 3 minus x, and then there's a type constant plus 3. So this is the hard way. Now we're going to look at the easy way, or the easier way. So any questions about that? So let's say we're going to do the same multiplication. We're going to do this. Now, this is what's called the column method. And what we're going to end up doing is taking each term in the bottom of this polynomial, or each term in the bottom polynomial, and distribute it to each term in the top polynomial. And so this is our constant column, our x column, and x squared. Then we're going to have an x cubed and an x to the fourth. So first off, x squared times 1 is x squared. x squared times x is going to be x cubed. And this is a positive x squared, so we'll give it a plus. This is also a positive x cubed. Then x squared times 2x squared is 2x to the 4. All right, so we've distributed the x squared. Now we're going to distribute the negative 4x. And again, it's going to take the sign with it. So negative 4x times 1 is negative 4x. That's going to go in the negative 4x here in the x column, where all the x terms are. Negative 4x times x, negative 4x squared, goes in the x squared column. The negative 4x times 2x squared is minus 8x cubed. And then we're done. Now let's go to the 3. 3 times 1 is 3. So that's going to go in this constants column. It's a plus 3. 3 times x is positive 3x. 3 times 2x squared is positive 6x squared. So now we're just going to add everything up. Yeah, 3, negative 4 plus 3 is minus x. This is a positive 3. 1 minus 4 plus 6, that's going to be positive 3x squared. X cubed minus 8x cubed, negative 7x cubed. And then this, well, it's just going to be 2x to the 4th. So that's the column method. So either method is going to work. Either one will work. So questions about that? Now, there are other shortcuts, and you don't have to use these shortcuts, but you can use them. And the first one is the square of a binomial. And it works like this: a plus b squared is a squared plus 2ab plus b squared. And just like with FOIL, we're looking for ways to come up with shortcuts to do these polynomial multiplications faster. So let's say we have something like this. Now what you could do, you could write this as 3x plus 2 times 3x plus 2. That's what the squared means. And then you could FOIL or distribute this to each of the terms, or you could use the column method, and that would get you the right answer. That would be perfectly fine. But we're going to use this shortcut. And the idea is this. This will be A, and this will be B. So that means a squared plus 2ab plus b squared. And this will become 3x squared plus 2 times 3x times 2 plus 2 squared. So So there's our a squared, 2ab, b squared. So this will become 9x squared plus 12x plus 4. Questions about that? Now there's another version of this problem, and it's when you have a minus in here. So let's say we have this. The key to this problem is rewrite the minus as adding a negative. So that's our A and that's our B. So we have a squared plus 2ab plus b squared, or 6x squared plus 6x times minus 10y. There's our A, there's our B, plus minus 10y squared. So this will be 36x squared. 2 times 6 times 10 is negative 120. So that becomes a minus 120. We have an x and a y. Negative 10 squared is 100. Negative 10 times negative 10 is positive 100. And then we square the y. And that's going to be your answer. Questions about that? All right. So the other kind of shortcut that we looked at in this section was this. A plus b times a minus b. This is the same as a minus b, a plus b, or a squared minus b squared. You're going to get the same result, whether it's this or whether it's that. You're going to get this. So let's say we have this. Well, again, we want to identify A and B. So this is the, well, let me change the variables here because they're going to get kind of confused with our formula. I'll call this X. So this is A. Now this one, you got to be a little careful. For this one, we don't bring in the sign. So the minus sign doesn't go with the 7 when using this formula. So we'll have a squared minus b squared, or 2x squared minus 7 squared. That's going to be 4x squared minus 49. And that's going to be the answer. Now, again, if you don't remember the shortcut, you could just FOIL this, and that would be okay. And when you FOIL it, then the minus sign does count. That will attach to this inner term. So if you don't remember the shortcuts, you could FOIL. That would work also. Just kind of a question I want to point out. If you encounter something like this, you could rewrite this as 2x plus 3 squared times 2x plus 3. And then compute this first. And you can use your a squared plus 2ab plus b squared. And what you're going to get, for the sake of time, I'm just going to give the answer. You'll get something like this. Times 2x plus 3. Let me double check my figures there. Okay. And then you could compute this, either distributing 2x plus 3 to each of these terms, or you could use the column method. And sort of another advancement of the rainbow method, again, that's what the student came up with. I thought this was really clever. You can do the column method sort of in much faster, or maybe much faster. But each term here gets multiplied to each term here. And so what that's going to give you is 8x cubed plus 24x squared plus 18x plus 12x squared plus 36x plus 27. So this is an even faster way. It's technically the column method. And so if we combine like terms, 24x squared, 12x squared, 36x squared. Let me just make sure I didn't make an algebra error here. Okay, that looks good. Okay. It's easy to make an algebra error. 36, 27. Okay, we're doing good. And then the x terms go together. So that's 46, 54, and then plus 27. So this rainbow method, and again, a student of mine came up with this. I thought this was really clever. You can do, this is basically the column method, except a little faster, maybe much faster, to be honest. So questions about that? So section 4.7, we're dividing polynomials by monomials. So let's say we have this. I just want to point out that the top polynomial is not what we call standard form. In standard form, now for this problem, we won't need standard form, but in the next section, 4.8, we will. But usually we list the terms with the term with the highest degree, and then the term with the next highest degree, and then the term with the lowest degree. So we go negative 18x to the fourth. We're going to put this in standard form. And we might as well. We'll get in the habit. And again, for this problem, we don't have to, but for the next section, we definitely will. Be critical. So now it's in standard form. So the key to dividing a polynomial by a monomial we're going to break up the polynomial so each term is getting a denominator. It's the same denominator. So questions about that? And we can simplify these signs here. Negative and negative is going to be positive. Again, negative and negative will be positive. But then positive and negative, that's going to be negative. And so we simplify like we did when we took ratios of monomials. We divided monomial by monomial. Yeah. So 18 divided by 18 is 1. This will be x to the 4 minus 3. Now this is going to be a fraction, 9 over 18. That reduces to 1/2. And then this will be x to the 3 minus 3. Now this is also a fraction, 27 over 18. And we can reduce it. It's both 27 and 18 are divisible by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. We're going to have x to the 2 minus 3. Again, top exponent minus bottom. We're always going to do that. So this will be x to the 1 plus 1/2 x to the 0 minus 3/2 x to the minus 1. So now we got to clean this up a little bit. Now again, we're assuming that this is a situation where x isn't equal to 0. So anything to the 0 power, as long as it's not 0, that's going to be 1. So this right here will become a 1. So we get 1/2 times 1. And this, anything to the first power, is just itself. That's just going to be x. So let's go back up here. We'll start working with that. For x plus 1/2 minus 3/2. Now, this has a -1. You got to flip it. 1 over x to the 1. And again, x to the 1 is just x. So x plus 1/2 minus 3/2 times 1 over x. Now these, they're two fractions that are trying to be multiplied, so we're going to multiply those together. And so we get x plus 1/2 minus 3 over 2x. And that's going to be our answer. So any questions about that? So just one thing I want to show you, and for time's sake, we could actually go through this one. Let's say we have something like this. What we want to do, simplify the top first, divide last. Now this one we can FOIL. We're going to ignore this for now. But first times first will be 6x squared. Outer times outer, 4x. Inner times inner, 3x. And then last times last is 2. Then we've got the 6x squared. And we divide by 2x squared. Combine like terms. That type x squared, so that's going to be 12x squared. Type x, 7x plus 2 over 2x squared. And now we're going to break things up. So we have 12x squared over 2x squared plus 7x over 2x squared plus 2 over 2x squared. Well, 12 divided by 2 is 6. This will be, x to the 2 minus 2. This one, we're just going to get a fraction of 7/2 times x to the 1 minus 2. Or here, let me put this extra step in here. We'll just break this up into a variable fraction and a number fraction like this. And this is as far as it's going to reduce. It won't go any farther. Now this one, top and bottom are divisible by 2. We can divide by 2, divide by 2, and what we're going to get is 1 over x squared. Or another way of putting it, you can say the 2's cancel each other. And whenever you cancel something completely on the top or on the bottom, completely on the bottom, you just have a blank spot, put a 1. But you can think of it as dividing top and bottom by 2. So we get 6 x to the 0 plus 7 halves x to the, there's an invisible 1 there, 1 minus 2 plus, and this one's done, 1 over x squared. So x to the 0 is going to become 1, and again we're assuming that x is not 0 in this case. This will be x to the minus 1. So that's going to give us, well, any questions so far? All right. Yeah. 6 times 1 plus 7 halves times x to the minus 1 plus 1 over x squared. So this is going to be 6 plus 7 halves times, and we got to flip this, 1 over x to the 1 plus 1 over x squared. And again, x to the 1 is just x. 6 plus 7 halves, 1 over x plus 1 over x squared, or 6. And then fraction multiplication, we're just going to multiply across. 7 over 2x plus 1 over x squared. And that's going to be our answer. Questions about that? All right. Let me see. Now we're going to get into section 4.8. Let me pull out a book here. There's something I want to look up. A little formula. Let me not see it. All right. Well, that's okay. We'll do this. So let's say we're going to do this division. Well, first off, you want to make sure everything's in standard form. So let me change this. Let's say we have this. So standard form is highest degree term, then the next highest degree until you get to the lowest degree. So that means the top will be x squared plus 5x plus 4. And then the bottom is going to be x, which is degree 1, plus 3, which is degree 0. Constants have a degree of 0. And then the way we're going to do this, we put it in long division form. Now, what's going to be doing all the work is that x. That's going to be doing all the work. So we go first term divided by first term. So x squared divided by x, and that's going to give you x. So when we do this first term by first term division, the result, that's going to be part of our answer. So this is an x term. We'll put our answer over that x term because it's a type x term. Next, we take that answer and we multiply it to the divisor, the entire divisor, not just the first term, the whole thing. And that's going to give us x squared plus 3x. And then we subtract. We're always going to subtract. X squared minus x squared is 0. 5x minus a positive 3x is 2x. We bring down the next term, and we're done with our first cycle of division. And so now we move on to the second cycle. Except this time, we're going to be using this and this. So 2x divided by x, that's going to be equal to 2. It's a positive 2, so you have a plus 2. You have it over the constant here. Then we take that positive 2, we multiply it to the entire divisor. And that's going to give us 2x plus 6. And then we subtract. So 2x minus 2x is 0. 4 minus 6 is negative 2. And there are no more terms to bring down, so we're done. We finished our second cycle of division. So what do we have? Well, what we have for an answer is x plus 2 remainder negative 2. Or the way we're supposed to write this, x plus 2 plus the remainder divided by the divisor. Or what we typically do, as you oftentimes see this written, is you bring the minus out front. Minus 2 over x plus 3. But either of these is the answer. This one, XYZ won't accept, though. But these two, it should accept either one. If it doesn't, let me know. Send me a message. And I can get it, as long as it's the correct answer, I can give you credit for it. So any questions about that? And if there's no remainder, if you had to if this was 0, then only that would be our answer. So let's do another. Now this one has some problems. Oh, we have a degree 1, degree 0. It's in standard form. That's great. This is also in standard form. Degree 3, degree 0. As you go from left to right, that's also great. But to do this long division, we need all the in-between degrees also. We need a degree 2 and a degree 1 term in that numerator. So there's a clever way of fixing that. We add 0 x squared, 0x minus 8 over x minus 2. Because 0 times x squared is going to be 0. 0 times x is 0. So these actually, you could say, argue, don't really exist, but well, in a sense, from a placeholder point of view, they do. So this is the same as that. So let's do our division. And again, we're going to do it using long division form. So once again, this is going to be doing all the work. And we go first term and first term. X cubed divided by x is x squared. So we put an x squared in the x squared column. And then we take the x squared and multiply it to the entire divisor, x minus 2. And that's going to get us x cubed minus 2x squared. Now we got to be careful here. X cubed minus x cubed is 0. This one, though, this is 0 minus a negative. Don't want to forget the reference, this minus also. So 0 minus minus, that's a double negative. So it becomes 0 plus 2x squared, or 2x squared. Bring down the next term. And that finishes our first cycle of division. Now we do the second cycle. It's going to be 2x squared divided by x. And that's going to come out to 2x. So then 2x times the divisor will get 2x squared minus 4x. So 2x squared minus 2x squared is 0. Again, we got to be careful. 0 minus a negative, double negative will be positive. So it becomes 0 plus 4x, or 4x. Bring down the next term, it's a -8. And then that's the end of our second cycle of division. First term, first term. Get a +4. There's a +4. A +4 times the divisor we get 4x -8. So we have no remainder. So what's our answer? Well, it's just going to be the x² plus 2x plus 4. Questions about that? All right, here, I'm going to do one more. Now, do we have any missing terms? No, we got degree 2, degree 1, degree 0, and it's in standard form, left to right. You get smaller degrees. Degree 3, degree 2, degree 1, degree 0. It's decreasing left to right in degree. So this is perfectly fine. So we can just go right to the division. So what's going to be doing all the work, this lead term, which is now a 3x². It's been x the whole time. It's a little more complicated. So again, first term, first term. Divide these, we get 2x. And a 2x in the x column. Then we multiply the entire divisor. And so this will be 6x³ minus 2x² plus 2x. So subtracting 6x³ minus 6x³ is 0. 7x² minus -2x². So it's again that double negative. So it's going to become 7x squared plus 2x squared, or 9x squared. Then minus x, subtract 2x, like minus 1, subtract 2. So it's minus 1 degrees, got 2 degrees colder, it's minus 3x. Bring down that last term, and that ends the first cycle of our division. So for the second cycle, first term. So let's see if I can squeeze this down here. 9x squared divided by 3x squared. Well, that's going to be equal to 3. I have to go backwards. I have 3. Oh, I put in my plus 3. So now that 3 multiplies the entire divisor. To go this other direction, we'll get 9x squared minus 3x plus 3. And we subtract, and anything subtract itself, it's just going to be 0. So we only needed 2 cycles of division for this one. So what's our answer going to be? Well, it's just going to be 2x plus 3. And that's going to be it. So that's the review for chapter 4. I hope this helps. The only thing I would mention is that, again, with the review, it's not always comprehensive. There are going to be certain types of problems that I missed. So you want to go through and look for any types of problems I didn't do. Also, watching a review, writing a review, in other words, taking notes, and then doing the problems are 2 different things. You want to make sure you practice problems. The review is the kind of iron out little pieces here and there that you might have forgotten or that were giving you a hard time. But the way to study for the test, practice those problems. So that's it. If you have any questions, let me know. There's no lab assignment for today. So let me know if you have any questions. Other than that, good luck studying and have a great day.